So we were learning how to do cyclo or alkenes and alkynes. So we're going to work through these together, and as we go through these, I'll talk about the rules that aren't explicitly stated on page 14. So it just kind of takes practice and exposure of seeing these different molecules. So we named 3-methyl cyclohexene last time we met, and we learned that the double bond is always number 1. So in this molecule, how would you go about numbering your ring, knowing that the alkene is always number 1?
Because the double or triple bond always has like the lowest number.
Right. So initially, when students are looking at the structure and thinking, how would I go about naming it? You would say 1, 2, 3, 4, but that doesn't take into consideration how important the double bond is. So the double bond is always number 1. So you can number this way: 1, 2, 3, 4, 5, or the other way. But the double bond is always between carbons 1 and 2. So this would be 3,5-dimethyl cycloalkenes. Now on your cycloalkenes and alkanes, it's very easy to forget the cyclo. So be careful. Don't leave that out. You know, if this were a 3-point question, that might be a half a point or a point off, depending what else is there.
And also, with the cycle, you don't have to identify them.
Right, you don't have to say 1 cyclopentene because it's always number 1. So it would be redundant to say that. Sometimes it's good to have double, but for IUPAC, they're pretty particular because, every additional number could add confusion. All right, what about this structure here? So this is not a cyclo. So find the longest continuous chain of carbons that contains the double bond. So 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So I'm getting 6. Which way would you number?
From left to right.
From left to right. So 1, 2, 3, 4, 5, 6. And so it's 5, 5, dimethyl, 2, hexene. Now that we've been working on cycloalkenes for a while, it's very easy to forget that number when you have just the straight chain alkane or alkene. Questions on that one?
So, sorry, and I think you said this, but I must have dozed off for a second. I don't know. And that first one up there where that double bond is how it's always 1, it's because that double bond can really move anywhere around in there.
Right. Whenever you name your cycloalkenes, the double bond is always number 1.
Okay.
That's where you start your numbers. So in this one, it's always number 1.
So if you had to draw it in reverse, you would just know based on where that 3 of that methyl group is that you've got to count backwards to get the double bond where 1 would be.
Right. All right. And this structure, what's the longest continuous chain of carbons that contains your double bond? 5. You number left to right. So your parent is going to be called what? 1 pentene. So that double bond could be between carbons 2 and 3 or carbons 1 and 2. So I still have to say 1 pentene. And then what groups do I have coming off this one pentene? Nitro, amino, and a methyl. Which gets listed first? Good. So 4 amino, 3 methyl, 3 nitro, 1 pentene. All right, this, what's the functional group called? What is it called when you have 2 double bonds? Diene, right? So the double bonds take priority, and we're trying to give them the lowest number possible. So the easiest way would be to start off with 1 and give that the number 1. 1, 2, 3, 4, 5. So this would be called cyclopentane, but it's a diene. So remember, cyclopenta, add the diene. Because it's a diene, I need to have how many numbers? 2. So I'm going to list the lowest number. So 1, 3, cyclopentadiene. So whenever you have diene, you need to have 2 numbers. Just like when you have di, tri, tetra, penta in front of your other substituents. Now in the upcoming exam, your alkanes, your alkenes, your dienes, your diones, your alkynes, your cycloalkenes, they're all going to be mixed together. So, keep that in mind. Keeping these rules all straight is important. So, this next structure, what functional group do you see? What jumps out at you? Triple bond. When I find my parent in this molecule, what do I need to make sure of? It includes that triple bond. All right, so try to find the longest continuous chain of carbons that has the triple bond present. So you get 6, let's see. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 1, 2, 3, 4. Okay, I agree, 6. Right. And which way would I number? Yes, right where that triple bond is. All right, so 6 carbon parent with an alkyne. How would you name that? Hexyne. But you have to tell me where that triple bond is. 1 hexyne. Now, what else is on this 1 hexyne? Methyl, and ethyl. Which goes first? Ethyl. So 3 ethyl, 3, 4 dimethyl. Sorry, that's squunched together. So 3 ethyl, 3, 4 dimethyl, 1 hexyne. Exactly. Okay. I know there are all these little exceptions and nitpicky rules, and I often have students who, in this class, we get to organic, and they're burnt out and worn out with, oh my gosh, all these nomenclature rules. When am I ever going to use this in my nursing career, in my dental hygiene career, my respiratory therapy career? And it may be that when you're actively practicing, you won't be asked to name an ester or an ether or an alkyne. But it is very likely that you will have to follow rules that have exceptions and certain, little subtleties that are different from one another. So it's really practice for your life and, your future profession. And it took me a while to realize that because, once I've had students who've gone into the nursing profession and say, oh yeah, that is how it really is. Because this insurance company, you can file this way. This one you can't file that way. So maybe it won't be organic molecules, but it will be something similar with logic and reasoning that, hopefully you can apply. So, but it's the best way. It really does prepare you for these little exceptions. And, at different points they talk about medical school, we're not going to require organic chemistry. But it's hard to get this level of reasoning and logic tested. Organic chemistry is a beautiful way to do that. So, but I think those people who want to get rid of organic chemistry they don't want to take it.
It's a weed out course for pre-med, that's for sure.
Yeah. I always thought Chem 2.
That's why I'm not a doctor.
You didn't think Chem 2 was harder than organic?
No. Like the inorganic sequence, because they split, I guess it goes a little more in depth in this, but they had the inorganic 1, 2, and then the lab separate, and then the organic was the same 1, 2 in the lab, and second organic, that was but like I said, we lost a good professor who wasn't hitting the bell curve. Too many of us were getting A's and B's, and so they took a PhD who was their time to teach again.
Oh, I see.
And the final was just synthesize this from this molecule to this, and you had to do it in 2 pages. It was insanity. Yeah.
Well, that's too bad.
It's a little too much.
I see. All right, so let's do these 3. I want you to work these 3 on your own. And let me say, this, ChemDraw flipped it around on me. This is cyano. So cyano, you can see it either way. What cyano really is a carbon-nitrogen triple bond. But this functional group, the point of attachment is off the carbon. So the way it's drawn right now is clearly showing that the bond is from this carbon to this carbon, not to this nitrogen, if that makes sense. So you could see cyano written that way. Definitely know that it's cyano. These are from your blue flashcards. But I want you to name, actually let's do the rest of the structures on page 15. Work on naming those if you haven't named some of them already. Okay, so this first structure is 3-mercapto cyclobutene, sorry. And you don't need the number for the double bond because it's a cycloalkene. So 3-mercapto cyclobutene. The next structure, 1-cyano 3-hydroxy cyclopentane. And then this last one,
We can't have another carbon.
oh no, I've circled, you're right. Oh, good. So four fluoro, 2 pentine. All right. Now, I'm going to work the other way. Look this one. 1, 2, 3, 3-methyl cyclopropene. And the existence of this molecule is not very likely, and this goes beyond what we teach in this course, but 3 carbons, there's a lot of ring strain, so that ring just wants to keep opening up. So, and then to add a double bond, it really wants to open up. But it's nice to draw, to practice. It doesn't take up very much room, so we can practice drawing and naming it. Natalie.
So if it's on like a cycle, you don't have to put like one cyclopropene?
No, because the double bond is always number 1.
Okay, so you don't have to.
Okay, the center one, I get a lot of questions about this one. You have this ring. When it's hanging off a chain of more than 6 carbons, the chain with more than 6 carbons becomes the parent. So here is the parent. The parent is this one because it has 1, 2, 3, 4, 5, 6, 7. An alkane with 7 carbons, how would you name it? Heptane. And coming off the 3rd carbon is phenyl. It's not benzene. I'll talk about that a little bit later. This is phenyl. 3-phenyl heptane. And this last one, the longest continuous chain of carbons is 9. So that's nonane. Now, numbering wise, 1, 2, 3, 4, 5, 6, 7, 8, 9. So with that numbering scheme, I have numbers on the 3rd, 3, 5, 6, and 7. If I number the other way, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then I will get 3, 4, 5, 7. So when you compare these numbering schemes head to head, they don't look very different. But the one that wins is the one on the left, because 3 and 3 is the same, but 4 is lower than 5. So this is the winner. So the name that we're going to give to this, 4-ethyl 3,5,7 trimethyl nonane.
So you suggest like we do a chain like that, we should make it both ways. We should
Right.
always, because obviously it's like
Yes, and some of the numbering is really apparent to you. You know, like, oh, I'm trying to think of you know, like the 5,5-dimethyl-2-hexene. You know, the top right, the first row, top right. You can see that the double bond is closer to that end. But if you ever get into a situation like this, you know, definitely going through and figuring out the first point of difference is needed. But I agree, it does take a lot of time. So I wouldn't recommend doing this for all of them. Usually, you know, yeah. And I was pushing you on these, so. Questions about these that we went over?
I'm trying to name that.
What's that?
First name for that.
Oh, right here. 4-ethyl 3,5,7 trimethyl non-amine. I know it's not in the usual location.
And so, in that circumstance, we're numbering it so that not just the substituents have like the lowest numbers, but I'm trying to remember. I don't know if I'm confusing myself. Like when you have two, let's say you have two groups, how we usually number the smallest one to the one that comes first in the alphabet. But in this situation, it's just
Right.
one.
That more applies when you have two substituents on a cycloalkane,
Okay.
where they alphabetizing place. Like if it's a 1,3, if you have an amino on one carbon and then on the third carbon you have a nitro, then you would give the number 1 to amino and the 3 to nitro. Yeah. Did everybody get this one down? So on the next page, there are structures. I give you names and I want you to provide the structures. So more practice for this. So if you can move on to working those. What's that? You have a question? Yes.
Shouldn't that be a 1 instead of 4? Since the bond is on the lowest number?
Y'all can still be there. Yeah. All right, so work these for a little bit. Notice in these instructions that I don't tell you to draw a condensed structural formula or a complete structural formula. I just say structure. So you can always just do the skeletal. Those are the quickest way to draw structures. Remember, the skeletal don't have any hydrogens. It's just carbons, naked. So 2-octane, you could just 2, 4, 6, 8. 8 carbons on the second carbon. Between the second and third carbon, there's a triple bond. So, you know, if you're starting to fret about how many hydrogens to put on there, and oh my gosh, I don't want to have too many bonds to carbon. Ask yourself whether it needs to be a condensed structural formula. You know, on the exam, it could be that I don't ask you for the condensed structural formula. So, you know, keep that in mind. If I ask you for a structure, but I don't specify, you can draw a skeletal structure, and that saves you a lot of time. 2-propyl 1,4-pentadiene. That's start off with the parent, so that's 5. 1, 2, 3, 4, 5. Double bonds between the first and the second carbon, and then the fourth and the fifth. And then off the second carbon, you have 3 carbons in a row. The point of attachment's off the first carbon, so that's propyl. We had a good question from Natalie. Well, wouldn't this be the longest continuous chain of carbons? 1, 2, 3, 4, 5, 6, 7. Normally that would be the case, but because you have a diene, you want to have both double bonds and the parent. So, good question. All right. Very easy on these names that I give you to ignore things like you just don't want to acknowledge them. I'm not even going to pay attention to that, you know. Cyclo. Don't forget the cyclo. Cyclohexadiene. So that's a 6-membered ring. And then on the first and third carbon, wherever your first and third carbon are, mine are here. 1, 2, 3. Then off the first carbon, you have a T-butyl group. And if you're still kind of weak on your alkyl groups, practice, practice, practice. Those flashcards will help you tremendously. All right, 1,4-hexadiene. 1, 2, 4, 6. Three methyl, 1 heptine. Hept is 7. And then methyl is 1 carbon. And then 2,6 dimethyl 4-octine. So 1, 2, 3, 4. You have a triple bond. Off the second carbon, you have a methyl. Off the 6th carbon, you have a methyl. Questions on any of these? Which do you prefer?
Skeletal.
Skeletal, drawing from the names? Yeah. You'll get better at this, so keep practicing, keep plugging away at this.
The blank note packets are online, right?
Yes, the blank note packets are online.
So we can use that as more practice.
So you could just print out this page, you know, and do it again, or the other one that we just did.